Welcome back. We are in the sixth and final module on probability. And we have talked about some basics of probability, about experiments and outcomes. We have done some factorials, permutations, combinations. And now we are up to actually calculating the probability of a given event. So, excuse me, I'm still having some asthma issues, so my voice is just not very clear today, and I apologize. I want to start with the definition of probability. Probability is the study of how likely it is for an event to occur. And probability is all around us. If you play the lottery, you're dealing with probabilities. The weather forecast is a probability. What's the probability that rain is going to occur today or snow? There are probabilities in lots of different things. If you smoke, your probability of getting lung cancer, according to research, is higher. The chance is higher given certain factors. If you exercise, your probability of having heart disease is reduced. So there are probabilities, chance, risk-taking, odds in lots of aspects of life. So this is a type of math that can be very helpful to you in certain circumstances. And to illustrate probability, I want to have you to draw with me a hand. I do not play poker, so I cannot tell you what is good or what is not good in poker. My father was very good at it. He was able to keep a straight face and did not give away his hand, so he was very good. But I never acquired the skill. So I'm not even going to pretend that we're playing poker. I just want you to draw 5 cards. And they don't have to be perfect. Just sketch yourself 5 boxes. We've talked before about how I like pictures. They help me to visualize a problem. So in this given hand of cards, I want you to go ahead and make 4 of them be aces. And let's make the last one be a 10. And I'm just picking that at random. I have no idea if this is a good hand. I think it is. Those of you who play poker could tell me a lot. But I suspect this is good, but I don't really know. But I can still show you about probability. So looking at this hand, let's say that I could not see the numbers and that I just draw one at random. What's the probability or the likelihood that I would draw a king? Well, there is no probability of that. It's 0 because there's not a king in the stack. So that is an impossibility. There would be 0% chance. If there is not a king, there is no way I can draw it. So that would be impossible. And we'll talk about that in just a minute. What would be the probability that I would draw an ace or a 10? An ace or a 10. That's 100% because that's a sure thing, because that's all there is in the choices in the set of cards that I have to choose from. And again, when we get down here to the facts section, we'll talk more about that. But I want to show you how to do probability from a mathematical standpoint. And the formula is a little bit complicated. It looks funny, but once you see how it works, hopefully you will understand how to do these. So the general formula will have P capital P for probability, of an event is equivalent to a fraction of, these are called number of favorable outcomes. And just bear with me here. I will do some examples for you. Over the total number of outcomes. And you may be thinking that makes no sense, but it will, hopefully, after you see an example. But this is just the general probability formula. So if you go to college or on to post-secondary school, you may see this again. I would be very surprised if you do not see this again. So let me show you how this works. What if they ask me to find the probability of drawing an ace from this set of cards? So the way I would read that is the probability of an ace for this given set. So we set up our fraction. And to do this one, you take whatever's in there, and that goes on the top. So I ask myself, how many of those are there? How many aces are in this hand? And there are 4 of them. So that is a favorable outcome. That's what we want to get. How many cards are possible in this draw? How many cards are in the hand? And there are 5 of them. So that is your probability. It's 4 out of 5. The probability is 4 out of 5 that you would draw an ace if you just closed your eyes and picked one. Okay? So that's what we would call a ratio. And this is over here. You can express your probability in different ways. As a ratio or a comparison, it would be 4 over 5, the fraction 4 over 5. So if they ask you for a ratio answer, you would pick this one. They might have multiple choice ratios, and you're looking for 4 out of 5. So how would I do that as a number? To get the ratio to become a number, here's what you need to do. First of all, you need to know how to read your ratio, because this line means divide. So what that is saying is 4 divided by 5. And if you put that in your calculator, you're going to get 0.8. Let me just be sure of that. All calculators give a little different display. So 4 divided by 5 equals 0.8. Now you can turn that into a percent by moving your decimal. You can add all the zeros you want on the ends. So if you move your decimal 2 places for the percent, you get 80%. So 4 over 5, 0.8, and 80% are all the same thing. It just depends on how they want you to express your percentage or your probability of a given outcome. And they could choose to do it in any form. Some tests will ask you to do all 3 forms. So you need to know how to do those. Okay, before we get to the, let me go ahead and say this would be 0.8 or 80%. Let's do a few more examples here before we get to some facts. What if I asked you to find, and I'll change color so you can keep it straight, the probability of drawing a 10. So you set up your original fraction, and you remember this number, whatever's in the parentheses will be the number of outcomes on top, and there's only one 10 in the set of cards, but we still have 5 cards. So you could say that the probability of drawing a 10 is 1 out of 5, or if you put this in your calculator, 1 divided by 5, you get 0.2, or 20%. Okay. What if I asked you to give me the probability of drawing a queen out of that hand? So I'm going to close my eyes. I'm going to pick one of those cards that we drew in the picture, and I want to know the probability of getting a queen. What if I said, I'll bet you $1 million I can draw a queen out of that hand? What would you say? Well, hopefully you would say, no way, because there are 0 queens out of those 5 cards. So 0/5 is 0, or a 0% chance. It is impossible, because there were no queens in there to start with. So some of this, or to a certain extent, this is common sense. You have to think about it in really practical terms. And then once you get that fraction or that ratio, you can get your decimal and percent if you need it. So here are some facts about probability. These are just kind of some general rules that you need to know. And I'm going to put those in with an asterisk. The first fact, if something is impossible, the probability is 0. Or 0%. If something is certain, for example, if I say, what's the probability that it's going to get dark tonight in Tennessee? That's a certainty, because the earth is turning. It is going to happen. It has happened every day for as long as the earth has been turning, and it will continue to happen. That is according to science. So the probability that it will get dark tonight in Tennessee is 100%. It is 1. It is a sure thing. So the probability is 1 or 100% if something is going to happen. So if you think about it, let me give you a line. Probability is based on a scale of 0 to 1, where 0 is impossible and 1 is certain. And the closer you get to 0, the more unlikely things become. And the closer you get to 1, the more likely things are to happen. So, for example, if I give you an example, what is the probability that a baby will be born somewhere on Earth tomorrow? Now, I can't tell you that for certain, but that's very, very likely to happen. That somewhere on this earth tomorrow, a baby will be born. It will be born in America, it will be born in Russia. Is it possible that we could have a day where no babies are born at all? Yeah, I guess in theory it's possible, but it's a certainty for practical reasons. What is the probability that the oceans will disappear by the weekend? That the Pacific and the Atlantic and the Indian and the Arctic and the Southern Oceans will just disappear. That's an impossibility. So that is going to be more toward 0. And I'm making up really weird scenarios just to get you to think about what you're doing. What is the probability that I will eat tomorrow? Well, if you know me, that's almost a given. But it's possible that I could go through tomorrow without eating anything. If I were to get sick, I may not want to eat anything or may not be able to eat anything. So that's not as certain as things like the sunrise and the sunset. So different events have different probabilities. Some of them are certain and some of them are impossible. But you have to think about how likely it is to happen. Okay, here's one other thing I want you to know. If 2 events are equally likely, for example, if I flip a coin, it's equally likely that I'll get heads or tails. There's not, unless the coin is weighted or a fake coin in some way, those 2 events are equally likely. We call that a probability of 50% because it could go either way. And 50% on this line is right about there. The decimal is 0.5, the percent is 50%, this is 100%, and this is 0%. And sometimes it's easier to think about the percentages instead of the decimals. Even though they're the same, it's a little bit easier sometimes to see the percentages because they're in terms of whole numbers. But either way, you're talking about the same chance. Okay, I'm going to stop this video and I will see you in the next video where we'll do some more definitions and some examples. So I will see you soon.